Hi. Now let's look at a number sequence question. Okay, so the sequence that is given here is 1, 2 over 3, 4 over 7, 8 over 15, and 16 over 31. So in part A, we are asked to write down the next term in the sequence. Okay, so to do this, we would like to establish, some relationship between the current term and the next term. Okay, so to make all the numbers look consistent, let's just rewrite the numerator also as a fraction. So 1 is 1 over 1. And we will examine the relationship separately for numerator and the denominator. Okay, so from the numerator, you can see that the terms are always multiplied by 2. So the next term in the sequence is the previous numerator multiplied by 2. So this is a very clear and obvious relationship. So we know that the next numerator is going to be 32. Okay, how about the denominator? So in the denominator, we can establish a relationship from the numbers to say that is the previous denominator multiplied by 2 at 1. So 1 times 2 is 2 plus 1 is 3. Same thing here, times 2 plus 1 you get 7. So we observe that the relationship is consistent. Okay, so it will continue to hold true. So this is a plus sign here. Okay, plus 1. So this is will continue to hold true for the next sequence, next number in the sequence. So we will get 63 in the denominator. Okay, so that gives us the answer for part A, the next term in the sequence. For part B, we are told that the current term is x over y. So in terms of x and y, how do I find or represent the next term that immediately comes after the current xy? And this is actually what we just did, correct? We just established that the next term is the current term with the relationship for the numerator as multiplied by 2, and for the denominator is multiplied by 2 at 1. Alright? So this relationship is what we have just established from part A. The interesting part of this question is that for part B, actually we have multiple answers. Okay, so this is just one possible relationship. So let's examine the sequence again to look at other possible relationships. Okay, so let me rewrite the sequence over here. Okay, so you can observe that the numerator, what we will do is we will stick to it. Okay, since it is a very clear relationship, we will not do much with that. We will stick with the numerator as 2x. Okay, but for the denominator, we can see that another possible relationship is that the next denominator is the previous numerator multiplied by 4 subtract 1. 1 times 4 is 4 minus 1, you get 3. Same thing over here, 2 times 4 minus 1, you get 7. 4 times 4 minus 1, you get 15. Okay, so that relationship holds true all the way. So that gives us another possible answer, which says that the relationship is 2x for the numerator, and the denominator is 4x minus 1. Okay, so that is one other possible answer. Let's look at another possible answer. Okay, so let me rewrite the sequence again over here. So 1 over 1, 2 over 3, 4 over 7, 8 over 15, and 16 over 31. Okay, as mentioned earlier, I will stick with the numerator, which is multiplied by 2. Okay, and what is or what other way can I derive the next denominator? Okay, so I can see that if I add the new numerator with my previous denominator, I get the new denominator. Okay, 2 plus 1 I get 3, 4 plus 3 I get 7, 8 plus 7 I get 15, and 16 plus 15 I get 31. Okay, so rewriting that as a formula, I can represent it as 2x over 2x plus y. Okay, so you can see that I have 3 possible solutions to part B. Okay, to represent xy and the next term in the sequence. Okay, so let's go on to part C, which says, okay, so part B is done. So let's go on to part C, which says write down an expression in terms of n for the nth term in the sequence. Okay, so what we need to do now is now write down the numbers again. Okay, and then see the relationship that they can possibly have based on the nth term in the sequence. Okay, so let's write down the n value. So n, so for the first term n is 1, second term n is 2, n is 3, n is 4, n is 5. Okay, so what is the relationship that we can observe? Okay, so we see that for the numerator, okay, it is always 2 to the power of, in this case 1 is 2 to the power of 0, 2 is 2 to the power of 1, 4 is 2 to the power of 2, 8 is 2 cubed, and so on. And how is this power related to n? It is 1 less than n, correct? Okay, so we can see that the numerator is derived based on 1 power less than n. So in terms of n, I can say that the numerator is 2 to the power of n minus 1. Okay, how about the denominator? Okay, so for the denominator, we can see that, for example, here it is 2 to the power of n here, and this n here is 2 minus 1. Okay, 2 square is 4, 4 minus 1 is 3, 2 cubed minus 1 is 7. So this power here is based on the n value. So this power here is based on the n value here. Okay. Okay, so the denominator is derived from 2 to the power of n minus 1. Okay, so that gives me the relationship of the sequence based on the nth term in the sequence. Okay, so that's about it. Okay, so you can see that for a question like this, you need to observe the patterns, okay, and see the kind of relationship that you can get. Okay, is it a multiplication, is it a division, and is it some subtraction or some addition after that? Okay, and once you are able to see the pattern, then it becomes quite easy to solve. Okay, but seeing this initial pattern is the challenging part for such questions. Okay, that's about it. Thank you.